Hey guys, these are our notes from Intro to Statistics. We're going to be talking about measures of center and graphing data. So the first part we're going to talk about is just measures of center, which are mean, median, and mode. So when you're looking at data, you want to find the center of the data. Those are the three things that we would use. So the first one is the mean. The way that I remember the mean is it's just the average. When you're finding the average, you just add all your data and divide by the number of pieces. So for our data, you can write out your numbers. If you add them all up, I grab my calculator, I get 270. I divide that by 12 because that's how many pieces of data there are. That leaves me with 22.5. So the mean average is 22.5. The other measure of center, there's three of them, but the other one that we use most is the median, and that one will be the middle. That's how I remember the median is the middle. You just put all your data in order and find the middle number. If there's an even number of data though, you're going to have to average the middle two. So we have 12 pieces of data, therefore we're going to need to average the middle two. So first thing we're going to do is go ahead and put them in order from smallest to biggest. So it's the same numbers we had before. So there's 3 16s, a 20, a 21, there's 2 23s, a 25, a 26, and then 3 28s. Sure, I got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so if there was 5 pieces of data, the third one would be in the middle and there'd be 2 on each side. But when there's an even piece of data, like 12, there's 6 on each side. So we have to average together the middle 2. So we're going to find the middle 2 and average them together. So we count 1, 2, 3, 4, 5, 6. So it's this one. 1, 2, 3, 4, 5, 6. So it's this one. So the middle 2 that we're going to average together are 23 and 23. Well, that shouldn't be too hard to average 23 and 23. What's in between the two? Well, it's still going to be 23. We're going to show our work because if you guys are doing a different problem and you're trying to look back and you see that it's, 47 and 92, how do you find the average? You add them together, divide by 2. So the mean is 23. So the median is 23. So pretty close to the mean, which was 22.5. All right, the last one is mode, and we definitely don't use mode as often. The main two are the mean and median. So the mode is, I remember that one, is the most. You just see which data appears most often, or find the value that appears most often. So we already had our numbers up here. The 16 and the 28 both show up 3 times each. So there's actually 2 modes, 16 and 28. So it's possible to have multiple modes because they appear the same amount of numbers. It's also possible to have no mode. If every number only appears one time, then we say there's no mode. All right, our last one we're going to look at is the range. So the range is the spread. So that we looked at 3 measures of center, and then we look at spread. Spread is like how spread out your data. Your range is how spread out your data is. You just take your largest number minus the smallest. Largest data minus the smallest. So our biggest number was 28, our smallest number was 16, so you just subtract 28 minus 16, and that's 12. So the smaller your spread, the more reliable your data is. The bigger the spread, the kind of less reliable you could say it is. Next, we're going to talk about when to use which. So first, we can draw these little pictures. So the first one, this is what we call a symmetric curve or a bell curve. It's the same on both sides. There's most of the data is in the middle, and then there's a couple of high values and a couple of low values. The mean, median, and mode are all the same here. So the measure that we use if it is symmetric is the mean. Over here, this side is what we call skewed. Skewed data is where the majority of the data is over here, but there are very few answers over on the high side or the low side. Could be skewed left or it could be skewed right. What happens is that this one outlier over here is going to take and bring your mean up. So a real world example of this is like home values. Like most of the home values are all in here, but one outlier is going to bring your home values up. So they usually use, instead of the mean home values, they will use median, because even though the most lies over here, but there are some values that are kind of higher up or lower down that will change your mean. So we use the one that's in the middle, the median. So we'll write that down in word, or drew the pictures, and we'll kind of write it down in words what it means. So when data is symmetric, use mean with standard deviation, which is what we're taking our next notes on, or not our notes today, but the next day. And when the data is skewed, use median with IQR, which is the interquartile range. We're not really going to use this one as much in our Unit 1. We're mainly going to use the standard deviation with the mean. All right, so let's go ahead and take our notes on graphing data, and then here, well, you have some classwork problems that are practicing mean, median, mode, and then the homework is about graphing data. So flip your paper over, right? Use the following data to create a dot plot, histogram, and box plot. It's the same exact data we did with all of our other points. So no matter if you're making a dot plot, histogram, or box plot, you always want to start by putting your data in order. So we had 16, 16, 16, 20, 21, 2 23s, 25, 26, 3 28s. All right, so first we're going to make a dot plot. The way that you want to make a dot plot is you're just going to place evenly spaced points above the number line with no skipped numbers. So those are the two mistakes that can be easily made. Not being evenly spaced. If you did like 3 dots this way and then the next one you did 3 dots this way, then it will mess up your graph. And if you skip numbers down here, it will also mess up your graph. So you don't have to write every single number. Like my number started at 16. I don't have to write the number 17. Maybe I only write the evens, but there is still a space for it. I know it gets crammed if you write every single number, but you just have to make sure there's a space for it on your number line. Oops, that's a 26. This one's 27, but I don't write it, and then 28. So I didn't write every single number, but this is 17, this is 19, this is 21, the odds. All right, so then we go to our data. There's 3 16s. So I'm going to go to the number 16. I'm going to place 3 evenly spaced dots above there. And then number 20 gets 1. I try to make sure that they're, level. I get 21, 2 for number 23, 25, 26, and then 3 for 28. 8. And that is our dot plot. That's all it is. Our next one is a histogram. So a histogram is commonly mistaken with a bar graph. You need to draw your first quadrant. You don't have to worry about drawing the boxes or anything, but you need your 2 quadrants. Across the bottom, you're going to have your values. So we're going to do between like 0 and 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, and 25 to 30. And across the side, you have your frequency. So we have 1, 2, 3, 4, try to write sideways, 5. So what you're going to do is histogram is, like I said, it's commonly mistaken with a bar graph. A bar graph, you could have like blue, and then how many people like blue. So a histogram is more so like intervals. Okay, so you use an interval of numbers. So you're going to draw bars to represent the frequency of each interval. So between 0 and 5, these are our numbers up here. There's no numbers between 0 and 5. There's no numbers between 5 and 10. There's no numbers between 10 and 15, but there are numbers between 15 and 20. Okay, so between 15 and 20 means the number 15, the number 16, the number 17, the number 18, the number 19. We're not going to include 20. 20 is going to go with the other side, so it kind of goes to the right. So it goes 15, 16, 17, 18, 19, 19.99999, but we're not including the 20. So only these 3 numbers are going to fit there then, because we're not including the 20. So the frequency for our first bar between 15 and 20 is only 3, the 16, the 16, and the 16. Now between 20 and 25, we include 20, 21, 22, 23, 24, 24.99999. We're not including the 25. So from 20 to 23, these 4 go. The 25 is going to go with the next bar. So there's 4 for that bar, for the frequency. And then the last one's from 25 to 30. So 25, 26, 27, 28, 29.9.999, just not including 30. Wouldn't have to worry about that though, but it's the 25, 26, 28, 28, 28. So there's 5 for that one. So a dot plot, you can see each individual data piece and you know exactly what the numbers were. But with a bar graph, with a histogram, that looks like a bar graph, the histogram, you don't know like the exact values. You just know that there's 4 numbers that are between 20 and 25. We don't know what those numbers are, but we just know that the frequency of those numbers is there. All right, last one is our box plot. To draw a box plot, you're going to need 5 things: the minimum, maximum, the quartile 1, quartile 3, and the median. Okay, so use minimum and maximum as points. Q1 and Q3 to draw the box. And median through as a line through the box. So we're going to use the same numbers we've been using. So my number line's going to be the same. I have a 16, 17, but I'm not going to draw the odds. 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28 is my biggest piece of data. All right, so first we're going to use the minimum and maximum, Q1, Q3, and the median. So I need to go up to my numbers up here. Should be pretty easy to identify your minimum and maximum values. My minimum is 16. My maximum is 28. Now I need the median. So there's 12 pieces of data. This is where they get split in half. So what's in between 23 and 23? We found that earlier. It's just 23. So here's how you find your Q1 and Q3, your quartile ones. So we have this half over here, and we have this half over here, and we're just gonna find the median of the blue half and the median of the green half. So you just cut it in half at the median and then just find the other median of that half. So like in a football game, quarter 1's in the middle of the first half and quarter 3 is in the middle of the second half. So here's where we would find our Q1, what's in between 16 and 20. So add 16 plus 20, divide by 2, you get 18. Q3 would be in between these two, because there's 3 here and 3 here. So in between 26 and 28, well, that's pretty easy. It's 27 would be directly in between. So those are the 5 values that we need. The minimum 18, minimum 16, Q1 18, median 23, Q3 27, and max 28. So when we draw our pieces, we're going to draw our dots at 16 and 28, but you don't draw them down here. You draw them kind of up in the middle at 16 and 28. That's our minimum and our maximum. Then I draw my box using Q1 and Q3. So Q1 was at 18, so I draw a line. Q3 was at 27, so at 18 and 27. And then I use those to draw the box. In the middle of the box, I'll have a line drawn through as the median. The median was right here at 23. So I just draw a line through my box at the number 23, and that's the median. And we just connect our little ends. So sometimes I call it a box and whiskers plot. Something that you need to be aware of is that 25% of your data lies in each piece. So what that means is that 25% of the data lies between 16 and 20. 25% of the data lies between 18 and 23. 25% of the data lies between 23 and 27. 25% of the data lies here. So it'll ask you questions like, what percent of the data is below 23? Well, half of the data is below 23 because this piece is 25 and this piece is 25. Or it'll say, what percent of the data is greater than 18? Well, here's 18. There's one piece is 25, 2 piece, 3 piece. So it'll be 75% is above 18. Okay, your notes are going to go in your new digital notebook, slide 4 and 5, and that's it.